Okay, so for the following circuit here, we have to use information from example 5.1 to solve the following circuit. And so we have to find the closed loop gain, and we have to find I/O. So in example 5.1, we were given the following information: voltage gain, input resistance, output resistance, and for Vs, in this case, it will be 1 volt. Okay, so what we're going to do is put our focus on this op amp. So inside this op amp, imagine there's this mini circuit here. So there'll be this input resistance, then there'll be this output resistance, and then there'll be this dependent voltage source, and then the ground. So here there'll be a voltage called VD. Its polarity will be determined by this. So the plus will be here, the minus will be here. Okay, and then here this is the input resistance. The input resistance will be 2 mega ohms, which is 2 million ohms. That comes from example 5.1. Now, this output resistance, it's going to be equal to 50 ohms. And then this dependent voltage source, its polarity will be opposite to this. So that means the plus will go here, the minus will go here. And it'll be equal to AVD. A being the voltage, the open loop voltage gain. So it'll be 2 times 10 to the power of 5 VD. Okay, now we can redraw the circuit, but include this portion and replace it with the op amp. So it'll be 1 volt. Hold on, there we go. And then we connect this to the ground. This is the 5 kilo ohm. This is the 2 million ohm. Then there's this 40 kilo ohm resistor. What else? So there's VO here. And then we're going to have this portion. This will be 50 ohms. And this will be 2 times 10 to the power of 5 VD. Okay? Now let me move this here. There we go. So yeah, we can draw the circuit like this. We can also, instead of doing it like this, we can draw it the other way. So we can actually have this go here, put the 50 ohm here, and put the voltage dependent voltage source here instead. Okay, and it has to be connected to the ground, so we can connect this to here, to the ground. So doing it in this way is also allowed. Alright, so let's call this region VA, and let's call this region VB. So we know that there will be a current IO passing through here. Okay, so the IO is passing through here, so now it's going to be passing through here now. We're going to be doing nodal analysis. So let's have I1 be here, I2 be here, I3 be here, and I4 be here. So for node VA, it will be I1 plus I2 plus I3. They're all leaving. So I1 will be VA minus 1 all over 2 million ohms plus VA minus 0 all over 5,000 ohms plus VA minus VB all over 40,000 ohms. Now for node VB, it's going to be I3, which is entering it, equals I4 plus IO, which are leaving it. So I3 will be VA minus VB all over 40,000. This will be equal to I4, which will be VB minus 0 all over 20,000, and then plus IO, which will be VB minus, so the voltage at this region will be minus 2 times 10 to the power of 5 VD, because pay attention to where the sign is pointing at. So it will be the following, like that, all over 50. So we can take out this negative, and then this turns into a positive. So we can leave like this. And now let's find a way to get rid of this VD. Okay. So what do we know? We know that the following VD will be here. Okay, because this is where the 2 million ohm resistor is. Its polarity is from here to here. Okay. So we see as we go from as the current moves from here to moves through here. So we start off with VA. We leave from this positive terminal, so that means there's a voltage increase. So it'll be plus VD, and it'll be equal to the voltage at this region, which is going to be 1 volt. So VD will be equal to 1 minus VA. Okay, so now let's start solving. So let's isolate for VA. So it'll be VA over 2 million minus 1 over 2 million plus VA over 5,000 plus VA over 40,000. And let's bring the VB to the other side. So it'll be VB all over 40,000. Okay, sounds good. Let's add up all of 3 of these. So 1 over 2 million plus 1 divided by 5,000 plus 1 divided by 40,000. And that gives me 2 times 255 times 10 to the power of minus 4 VA. And let me bring this to the other side as well. So it'll be VB over 40,000 plus 1 over 2 million. So it'll be 5 times 10 to the power of minus 7. Divide both sides with this value. So VA will be 1 over 40,000 divided by 2.255 times 10 to the power minus 4, which will be 0.1180, 0.11086 VB plus 5 times 10 to the minus 7 all over 2.255 times 10 to the minus 4, which gives me 2.2173 times 10 to the power of minus 3. Now let's take care of this equation. So let's break up all of these. Let's FOIL this into here. So it'll be plus 2 times 10 to the power of 5 all over 50 minus 2 times 10 to the power of 5 VA all over 50. Well, okay, so let's collect like terms. So let's bring this to the other side. So it'll be 1 over 40,000 plus 2 times 10 to the power of 5 divided by 50. That's 4,000.0. Okay, I'll just say 4,000 because the decimals are too big. VA. And let's bring this VB to the other side. So it'll be 1 over 40,000 plus 1 over 20,000 plus 1 over 50. And that's 0.020075 VB. Oh, wait, it should be equal to it. My bad. And then let's take care of this. 2 times 10 to the power of 5 divided by 50. That's 4,000. Okay, looks good. Let's plug this into here. So actually, let's divide everything by 4,000. So it'll be VA over 0.020075 divided by 4,000. And that's 5.01875 times 10 to the minus 6 plus 1. So let's put in VA. Oh wait, there should be a VB here. Sorry, I forgot to include that, but good thing we caught that in time. Alright, let's bring this to this side and let's bring this to the other side. So it'll be 0.11086 minus all of that, which is 0.118085 BB. And then it's 1 minus 2 times 2, 173 times 10 to the minus 3. That gives me 0.99778. BB will be equal to 9.0012. Okay, and we see here that VO will be equal to VB. Okay, because as we go down, so we have VB, and since we leave from the negative terminal, because I4 is moving down here, it's minus VO, and it'll be equal to the ground voltage, which will be 0. So VB equals VO. And to find the closed loop gain, it's VO over VS, and VS was 1. So that means this, since this is VO divided by VS, this will be 9.0012.